We're here to get your recollections of your involvement with the 1977 three-network transmission. So why don't we just start with a little bit of background from each of you. You're all from Rockwell Collins. And we've also got Don Nielsen here of SRI, and I'm Mark Weber. So Mike, do you want to just give a little brief background and capsule of your education and what brought you to Rockwell Collins?
Okay. My undergraduate work was at Oklahoma State University, and Dr. Jim Garrett actually showed up on campus one day of my interviewing, and so he actually hired me to Collins Radio in 1974. And the program I started on right away was the packet radio programs, basically what we called it. And later
Your name?
I'm sorry, Mike Cisco.
Yeah.
Is my name. And later I started working on my master's, but did not have the master's completed at the time of this experiment. And I was also working, I worked under both of these guys, Dr. Anant, Jain also. My main responsibility when I hired on was RF analog microwave hardware development, system integration. And that's just basically my background. I can tell you more about what we did with these experiments later.
Hi, I'm Dr. Jim Garrett. I joined Collins actually in 1967, right out of undergraduate school. I also went to Oklahoma State University, and was there for 3 years working as an RF design engineer. And those days, the new guys always got forced up in frequency, and so at the time, of course, Collins was big into HF and UHF. I got forced up into the microwave ranges, and actually was involved in designing the first solid-state microwave radio for Collins back in the late 60s. Went back to graduate school in 70 and graduated in 73 in electrical engineering. When I came back to Collins, I got assigned as a systems engineer on the DARPA packet radio project. In those days, we're still trying to sort out things like the frequency ranges of it and data rates, and there was some channel characterization activities going on. And we were also just trying to figure out a number of things as to how we were going to integrate this processor capability along with the transceiver capabilities into one radio, which was very unique at that time for Collins. And my career continued as system engineer, and eventually project engineer and principal investigator of the program. Can't remember exactly the years when that all took place, but certainly up until the late 70s was involved heavily in packet radio. My career then went on other directions, more on the business side. But this was, at the time, at Collins, one of the most interesting, exciting programs that we had. And we had some of the brightest engineers that Collins had in Dallas, Texas, working on it. And I think, I tried to count up, I think there must have been about 14 or 15 engineers that contributed to the design, both from the hybrid microelectronics part of it, all the way up through the processor and doing the software for that. The antenna design was a unique antenna design that Collins developed. And I think probably about 14 or 15 engineers and technicians were involved. I may be wrong on that number, but something on that order. It took about, from 73, I think it took us at least a couple of years before we had some prototype or the early stages of the packet radio working. And so there was a lot of work that went on, almost I think 3 years of work that went on before we even got to to this particular demonstration that took place in '77?
Yeah, my undergraduate is from University of Delhi in India. Then I came to University of Wisconsin, did my master's from there, and was hired into avionics and applied science department in Cedar Rapids, Iowa. And based on some mathematical skills I had, I was sent to Dallas to consult with a group. And it turned out I liked Dallas so much that I just decided to stay there. And
It's a lot warmer.
after a couple of years of helping out the department that I went to work for, I eventually ended up in the forefront of technology with the VLF area. Collins used to be, still is, a leader in the high-power transmitter VLF technology. And in about 1973, it was one of those interesting transitions that the department head who I used to work for, one day he called me, and because I was doing my PhD in those days while working at Collins, and he says, there's this little project starting, I think they call it a pocket radio, and with your mathematics background and some of the courses you are taking, maybe we figured we need somebody like you to go there and help out. So very soon I learned it was not pocket radio, it was something of the extension of the wireline ARPANET technology into the radio broadcast domain that we were supposed to be working on. So there were 3 or 4 of us. Jim had not joined about that time. I think he joined about 6 months later when we were in the middle of it. We started doing some experiments in support of SRI in the channel characterization. There was a guy named Paul Hertel who has passed away since then. He was one of the sort of senior, what we call as exemplary person in terms of a lot of hardware experience. We learned a great deal from him in doing some of that kind of stuff. Paul Hertel, Bob McGuire were 2 guys. Myself and Fran Dixon was the original guy who lined up this $100,000 study from DARPA, and that main scope of their study was to do the channel characterization for a spread spectrum channel. And eventually I ended up devoting myself to that area of spread spectrum signaling, which turned out to be the title of my PhD dissertation. So all of the codes that go in the packet radio, they were part of my dissertation outcome. So we used some Gole's complementary pair using minimum shift keying, MSK modulation techniques, direct sequence spread spectrum signaling. So we had, within short time after the characterization of the channel, we had picked up that 1710 to 1850 megahertz as the band of L band where we were going to deploy it. And in the packet radio, the encoder modulator was my design. And Mike Cisco, when Jim had already been on board, he brought this man who really helped both of us tremendously in terms of his ability to learn quickly. He was very persistent. He would come and ask hard questions. We would always be investigating after his questions and then diligently go follow through. And he was our guy on the road. Whatever we had to do, he would fly in here and bring the equipment, and very helpful. And we had an excellent team of people, like Jim mentioned. There was one time, Jim was the first principal investigator on the program, and I believe right after this experiment, he passed on the baton to me, and we carried the packet radio through the next generation. One time I used to have something of the order of 30 people reporting to me in my department, just working on packet radio. And this program helped all of us, Jim and myself included, in enhancing our careers at Collins. He went on to become the director of engineering, and I had the responsibility for all new development was under me one time at Rockwell Collins, including the VLF programs and any new development that occurred in the defense division I was in charge of that.
So in 1977, your official roles were what?
1977, Jim was the principal investigator. I was the project engineer.
And you were,
And I was a RF analog hardware design engineer.
and you, so just describe a little bit who was working on what at that particular slice, so around late 77.
Well, I was responsible for the entire packet radio, putting it together for Jim as the principal investigator. Mike was my implementer, sort of a principal implementer in the lab. There was a very key guy in this equation, that was Bob Marston. Bob is now parked somewhere in a trailer park in New Mexico. I tried to get him to come here, and I think either due to health or circumstances, he was not able to join us. And my role as a project engineer, my role also was the radio side of the world personally, but then I was the overall in charge of putting the radio together, and we had several engineers, including so the beauty of this was we were not so scattered like mostly in the companies are. We were a team of complete engineers. The digital guys, the software guys, they all reported to me to the benefit of this program.
And go.
Well, as principal investigator, my role at that time, we didn't call it that, but it was sort of what I would call a program manager role. Some involvement on the technical side, also a lot of involvement on the programmatics of it. This program, as Anant said, started fairly small with DARPA, but over the years actually became a fairly significant program. In fact, I think probably by the early 80s had probably done probably close to $30 million. And so it was big. I think it was big in SRI and a number of companies that were and institutions that were involved. But my role was, by this time, by 77, I was there in the 75, 76, kind of wringing our hands trying to get the first radio to work. And as Not mentioned, Bob Marsden was very key to the whole design of the radio, particularly the data recovery, demodulation portion of it. Dick Sunland was the software engineer who had the responsibility for doing all that machine coding of carrying out the protocols, et cetera, that the radio had to carry out. There was a Dale Walls who was a digital designer, and Don Heaton was also another digital designer. And then there's a number of people. I think Roy Shipley was involved in the hybrid design, and I should mention, and not mention just briefly, the late Fran Dixon had been sort of our leader and probably the first to contract with DARPA, and he was sort of the original principal investigator of the program. I followed him. So that was kind of my role during that period leading up and then during that time.
In 1975, I came across an old article before I came out here, and it reminded us that we at least had one of the first working EPRs. That stands for Experimental Packet Radio, where Anant and I were doing a little demonstration at one of the AFSIA conventions in Washington, D.C. So at least we had some hardware working by 75. There were three main builds of the phases of these: the EPR, the IPR, the I just stood for Improved Packet Radio, and a VPR, Value Engineered Packet Radio. As I got each build on its way, and the first one coming off the line, I literally flew a packet radio one at a time, about once a month, out here to SRI, and worked with all of the SRI team. They all, I worked close with all of them. They treated me like family, but especially very close with Don Cohn. We were in the lab and we would install these in their test network. Even before we had a Bay Area network, we were characterizing all of the specifications that we built the radio to, including bit error rate and packet loss rate and transmitted power, and waveform characterization. It was, in those days, very sophisticated with the computer test bed set up that they had, for us, that I would come out here. And once the packet radio proved its that it would function properly, and as SRI began to install the Bay Area net, we take them out in the various areas, and you'll hear more detail about that from SRI. But again, this was a very, very close working team. Many times I didn't even feel like I worked for Collins Radio. We worked for DARPA, and I also, of course, worked every day. My communications were with Don Cohn at SRI to get ready for the next experiment. This evolved later on to many fielded trips with the 82nd Airborne and the 9th ID when we did the Army Data. They got involved with the ADS program, the Army Data Distribution System. Went on every war game, that they had, along with all the other evolutionary proving of this equipment. But again, I guess I had the best of all world jobs because I was a design engineer. I would take all of the highly sophisticated designs from the people that you just heard about, not only these guys, but Bob Marson and then the digital side, Dale Walls. I worked with two outstanding super techs, technicians in the lab, Russ Whitaker and Glenn McLaren. Glenn was on the digital side, Russ was on the radio side. And those guys were just like, my right-hand engineers as far as putting this stuff together. And would get the hardware working. And then I had the freedom again to field all of it, go all over the world with it, working with SRI. So by this particular experiment in time, as was said last night quite often by the panel, we didn't really put emphasis on what we were doing at that time. It was another experiment. Now, it was a highly visible experiment, but then most were. We were either doing it for somebody very high up at DARPA, which was our customer, so obviously you don't want things to go wrong there, or we were doing it in shows in front of 1- and 3-star, 4-star generals. There was always the pressure and the importance of every experiment. Everybody just did their job, and we kept things working and move on to the next experiment.
Kind of a context issue. Was this the first time you had married RF and digital processor at Collins? And this was, I believe, I'd like to think this is the first mobile digital radio system.
I think so.
You were breaking new ground at Collins as well as other places. You want to
Absolutely.
speak about that integration?
Yeah, I want to particularly ask Jim to repeat the sentence that matched the Neil Armstrong sentence. When in the lab, we hooked up the two radios and the bits started flowing. And preceding that, what happened, Mike will tell you the story, what happened between me and him to make sure, because first time we fired it up, the correlation did not work, and then within minutes I figured out what was wrong, that TI had built the wrong surface acoustic wave devices. We sent him back to them, and we changed the memory. That was the modulator that we used to have was one of those impulse generator type of deals where we impulse the SAW device, and every bit it will give a code. So we found out they made some error in phasing, and instead of changing the SAW devices, we changed the driver, which was on a prom, and he went and got those proms burned again and returned within hours, and we fired it up, and Jim was in the lab, and say that sentence.
Well, this was after the Neil Armstrong had been on the moon, and it's still kind of fresh in our minds, and I was trying to think of something profound to say here at this point, and send a message over this. We had these two radios sitting there in the laboratory, and it came out one small packet for man, one giant message for mankind.
So I still remember that. I wanted him to repeat.
It obviously
that.
was profound. 30 years later, the people remember it.
It's a lot better than the invention of the telephone. He said, "What, Watson, I need you," or something.
Yeah,
Yeah.
exactly.
On just to follow up on what Anant was saying, it was a major step in getting this to work through some of the hardware that had never been done before. Collins Radio invented MSK, and that was the waveform minimum shift keying that we did, and we did that for reasons of spread spectrum, and which later turned out to be anti-jam characteristic because of the additional signal processing gain that you would get from that. But this person, Paul Hurdle, this senior technical person that he had mentioned earlier, handed me this design right out of college, and it was an impulse generator that wasn't quite working, but everything he did was in trifowler wound toroidal RF cores. I had no clue as to how to do that, and so I looked in Anant's office and took one of his old college transistor books, and saw a circuit in there that I thought would work. And so out of Meckel, which was Motorola emitter coupled logic, it was the fastest digital logic there. I mean, it was basically RF, but it was a digital chip. And I did a little design on that to create a transient that would hit a surface acoustic wave device, and that's what Anant was talking about. But the code, as he said, was off. Of course, I didn't know that. That was Anant's invention in the Golay code. I think Anant brought that by one day, and he had me check, after explaining the theory to me, he had me check every bit in the change, no change of the way that works for autocorrelation, bit by bit. I'm sure it was more of a training exercise. I don't think he was wanting me to tell him anything. So we went through that. It all checked out. And then I did do the prom, and it worked, but it was not a usable signal. It looked like it would work. We had the surface acoustic wave device, which the solid filter made. Now, Collins Radio had a thick film and thin film hybrid microelectronics group, but it wasn't quite up to the techniques that we needed for this. So that's why he mentioned TI South Lab, South Building, that I went to have the first one made. And it also didn't work, but it was more promising. It just had way too much insertion loss. Went back to this guy named Steve Miller, and I said, "Steve, this isn't going to quite work." He said, "Okay, come back in 3 months." I did, popped it in the module, perfect. Everything was perfect. I said, "Steve, what'd you do?" "Well, we didn't think the first thing you were doing, you were really serious about it, and we made it out of crystal. So when it looked like you were going to have something that might be feasible in this technology, we made this one out of lithium niobate, which was a lot less lossy. And that was the culmination of the SOD module working. And without that, of course, we couldn't go further. Now, there were several other thresholds with each module, almost bit synchronization that Bob Marson did for mobile type characteristics.
Multipath.
But and to handle multipath
And we have by the way, Bob Marston and I have a patent on the surface acoustic wave apparatus. So that was done in the same time frame.
Why did you go to spread spectrum? Was that an internal decision, or did Bob Kahn say that?
I think Bob was hot for that. He used to have that thought process. He saw the way the spectrum had been divided up into these individual channels. He liked to think about, well, let's just stack it up like pancakes, and the idea, at least theoretically, seemed pretty good. Of course, from a practical point of view, to get the whole spectrum reassigned in that way was very difficult.
Also, multipath was a consideration too, because he could see where we would be deploying this, and the programmer was always geared eventually for Army, for battlefield type of motivation. We wanted to have a single channel multiple access system that could be quickly deployed with the troops on the move. We were fighting the Russians in those days. And the whole idea was that this system, because DARPA's mission was whatever they did was eventually for defense applications. So we wanted to have some processing gain, in the radio channel in terms of AJ capability. And in fact, I'm glad you asked that question, because the story of the packet radio in the proper context will be incomplete without the next phase of it, which was the UPR, where we enhanced the processing gain by another 10 dB. We used to have the upgraded packet radios that we built 3 of later on. And it was always one of those issues. We did significant amount of studies at that time, because JTIDS was a system, the contending system from a radio channel point of view in terms of, AJ point of view, whether to have a frequency hopping system or a code division multiple access. So we wanted to use a system which would do code hopping. So that's what the upgraded packet radio was. So in terms of code division multiple access, it was invented on this. The whole idea implemented in the upgraded packet radio as a contender to the JTIDS program.
Yeah, the other thing about the direct sequence also is you could resolve the multipath. I mean, you would get out of the match filter, you get individual impulses or as that could be resolved. And actually, those first designs were in fact to put a time window over that, and so you wouldn't continue to be misled by the multipath, because the multipath would bounce off the buildings, et cetera, as you're driving through the urban areas, and you get nulls and peaks, and to meet the bit error rates, I think at the time were like 10 to the minus fifth, something like that.
10 minus fifth.
And that you had to overcome that. So that was another reason for spread spectrum. And of course, as Anant said, the code division multiple access came later in the upgraded, when we actually had a convolutional codes and an active match filter where you could put different codes in and they could be changing, in fact, on a bit by bit basis, which a pretty significant step forward from those original experimental packet radios.
I remember we could even see the multipath effects from, I think this was an experiment or just a test bed, initial experiment around Lincoln Labs or MIT. And the result of it was because large tractor trailer trucks with their aluminum sides, were driving by. And so there was a lot of characterization.
Yeah. The other thing about technology, I gave you that photo of the RF hybrid, and that was probably talking about Collins and what was going on at the time, that probably was one of the largest integrations of microwave integrated circuit technology in one thing, in one device. And it has everything in it. It's a full transceiver from the RF at 1710 to 1850 megahertz. There was a circulator and transmitter that was at 5 watts or 10 watts?
10 watts.
10 watts.
There's a lot of power in
which
those
is a
days
lot
for
in that time frame. And
1500 megahertz receive LO from our synthesizer.
And it came out, I think it did the mixing and
300
down
megahertz.
conversion down to an IF frequency, and so it had a lot in it. And I think, as I recall, I think those things weren't they around $10,000, which was a lot at the time, obviously.
Didn't Bob also factor in the choice of frequency range in which this would work? Or who chose the frequency range?
We did. This was something that we had the contract to decide the band where we'll deploy the system.
In fact, I think I'd actually, when I came on the project, I think the first thing I did was I did the filings with ECAC to get those experimental bands.
There's something about the frequency range that's a little ironic. I have pictures, or somebody has pictures of here's this radio, cubic foot of radio. And particularly when you got to the tough propagation environments in Fort Bragg later, but even the Bay Area, some places, this doesn't work very well in trees and everything. So here you have this cubic foot radio, and I remember when we went to Fort Bragg at one point, it took a low boy to bring the crane that would erect this small antenna that was a vertically
Collinear array, yeah.
above the tree level, so this thing would work. And so here was this nice little notion that we got this packet radio. In those days, it was a fairly small radio. Here's this antenna that goes on top of it. But anytime you were in a forested environment, it wouldn't work. And
Well-
so you had to get it above the tree line.
The
Yeah,
whole
that's,
idea was to have I think the notion was, the scenario was that, let's say you're fighting a war in Eastern Europe somewhere.
Hold the gap.
So
the
the
gap.
whole,
That was
the
a big
whole
term
idea
then
was
at
you
the
have
time.
to go deploy some of these things somewhat strategically ahead of time in anticipation of going through that area.
Yeah, some, I guess, background stories on that. It's a good thing I was still young at the time, because for exactly what you said, that's the tree bark in heavily dense areas is very absorptive of that frequency. And so I climbed a lot of trees. I climbed the birch trees in Alaska, and I would climb with the coax and the antenna just strapped to my waist, and then lash it around the highest part of the center of the trunk, or climb a banded 200-foot fire towers in the Washington rainforest. But you're right.
Hazard pay.
And I cussed that frequency more often than anybody else probably, because I was always trying. And Dr. Doug Hagen thought I was a hero at one of the experiments, because one of the repeaters was not getting through. It was real intermittent. And all I did was I went out in the middle of the night, and there was a clear moon. And I knew that I was in line with the moon, but there was foliage all around. So I tilted the packet radio antenna, which it was on the ground, I couldn't get, to be in line with that gap through the moon. And all of a sudden, those little LED lights, the receive lights, started blinking, and everything came up. And I went back to the base, to the main base, and he said, "What'd you do? What'd you do?" Of course, they think I tore modules apart right there in the middle of the night and probably did some solder repair or something.
Just tilted it over a little bit.
Just tilted it over until you could make the connectivity because of the foliage of the forest, just like you said.
Well, I
Can
think
I
also
ask why you
those-
didn't do more tests in the winter then?
In the
he's
winter,
got some photos of it in the winter too.
When there's no leaves?
it was year round. It was
Yeah.
year round.
Well, I think that antenna had a vertical. The radiation pattern was tended to go up too, didn't it? I mean,
Yes.
it was omni and it was up, elevated a little bit.
I think this spread spectrum question, because for the microwave community, this was a new experience to have to come up with the radio with spread spectrum. And I'm going to go back to Paul Hurtle's story again, because he was the old classical microwave guy, and he couldn't understand why would you unnecessarily waste so much of channel.
Sometimes they would be.
Sometimes at Collins, sometimes at BB&N.
The thing that was, I think, interesting about that
Are we on now?
Yeah, we're on.
is when it came to the interaction of the working group, is it was really a kind of eclectic group of folks, and we were probably from the radio design point of view, probably kind of the odd duck in some ways, because we'd go to these meetings, and a lot of those meetings were occupied by long discussions of protocols and counterexamples to a protocol, whether it was transport or end-to-end. And as I mentioned last night, the challenge was, and Dick Sunderland had a lot of the responsibility for, trying to take those protocols that were still in rather undefined states at times as to how to actually implement them, and put those into really crude microprocessor system, which I think he had to program all that in machine language, and so that was a major part of the activity. And unfortunately, you kind of got some guys that probably were probably more comfortable with the hardware than we were with the software. But looking back on that and thinking about all those folks that were involved, it was an interesting communications and educational process for us to do that part of the work, because it was quite different than what Collins had done in the past.
And also Dick Sunderland, I remember that Collins did have a significant play in the area of C systems that we used to call it. And so he was very familiar in terms of computer controlled communications because he was involved with the C systems. It is with that background that we brought him on this project to lead the team of software engineers who will be. And the way we implemented the radio and digital functions was that pretty soon we realized that this radio needs to act generically as a repeater. That when you hook up a teletype-like device, it becomes a terminal. You hook up a PDP-11 type of device, becomes a station function, and eventually we migrated into a stationless network also, where you don't need any such big device. So we gradually evolved those functions also in the sense of having a radio computer control. But in terms of protocol, as far as TCP, for instance, is concerned, because we were heavily on the TCP, on the terminal side, we worked in a very integrated fashion with the SRI and BBNN folks to implement all the TCP IP protocols. Our group was integrated. It was not isolated from the overall integration of the protocols.
And it wasn't to be done just as a stationary repeater, but as we've said, a mobile repeater.
Yes.
On the move, but also if that repeater died for some reason, either hardware-wise, it just quit, or in the combat scenario, if that particular repeater got blown up, the alt routing software was transparent to all of the other nodes. And it would just figure out, okay, that guy's not there anymore. I'm going to reroute all of the information so that all other nodes were successful in their transmission or receive.
Now, I was talking to that about Paul Hurtle's story too. I'd like to complete that. The motivation for some of these old classical guys, they never understood why you would put spread spectrum in something like this. And I just want to bring that for the sake of it sounded funny to me the way he described, so I will just repeat to you. We went in the very early days, we were sitting in a meeting, and he says, I never understand what would you do? Just think of it. If you turned on a fountain in the city of Richardson, it is like this big gigantic fountain, then you got a little bucket sitting here and collecting these drips of water. That was his model of spread spectrum communication, and my response to Paul Hurtle at that time was, Paul, but imagine this, that at least you are able to collect the water. That's the important thing, that in this kind of situation that we are dealing with, he said, well, there's something to be said there, because anytime you have these microwave type of systems, you never know whether the signal will eventually be captured or not. So that was kind of,
well,
he was a very, I'm talking about the generation of people who really thought things in a very practical term, and so for them to migrate from these kinds of principles to spread spectrum was really some took some cultural
shock. Kind of counterculture, because like things like minimum shift keying, which is really how to more efficiently transfer information in a less bandwidth. It was, you know, being in the microwave business, as Paul and a lot of the experience had been of the engineers was sort of counterintuitive to what one would think would be the best thing to do.
Well, this whole project was quite counter to.
Yeah.
Yes.
You know, the other thing that maybe that doesn't come through, and now, of course, hindsight, you know, everybody looks at the civil applications and what this has all become and its relationship to internetworking and the internet. But really, the real focus, particularly at Collins, I think, was on military communications.
Mobile.
And this was really intended, because at the time there weren't very many computers that needed to communicate with each other. And the real thought was things like artillery, battery-controlled computers, and other computers that were being considered to be put on the battlefield, was how were they going to provide a command, control, and communication with that.
And so, tactical, it's on the move.
And so all of our thoughts were really very much focused on that, with the idea of hopefully at some point developing a production tactical data communication system.
So what was it like to go to SRI for one of these packet radio meetings?
It was great.
Oh yeah, that's
Go to Ricky's and
Did you get along with Don Nielsen?
always got along with Don.
oh yeah. Don was the best man we could have interacted with. Very, very thorough gentleman and big motivator.
Yeah. There were some big personalities in that group. I mean, they weren't all as easy to deal with. I made the mention last night. You know, at least I don't. You know, Bob and Ben aren't my customer anymore. So you know, you kind of can treat them as peers. But Bob was demanding. There were some people that were very proud of what they thought they brought to the table, and it was a wide spectrum of very, very bright people. I mean, Leonard Kleinrock's and Howard Franks. I don't really even know what's happened to Howard Frank at this point, but lots of very capable people with an understanding of this whole area.
Yeah, I recall in terms of really admiring the vision that these guys brought to us for us to implement. From time to time, some of how far out they could think was also something for us young engineers, and they were young too, but for us to kind of be motivated by that vision. One of the visions Bob had, you know, talking about self-organizing networks and things like this in terms of this environment. One time in our, you know, we had Bob in the cloud room, if you remember, that we had a packet radio working group meeting there. And Bob
That
kind
was a
of,
room. It was a conference room.
yeah, and he gave his vision of what a self-organizing network for military applications could be. That one of these days when the technology really gets down to miniaturization, I can see little bitty packet radios with small antennas sticking out that you just throw hundreds and hundreds of those from the airplane and let them go hit the ocean, and with the impact of the water, the radios will turn on, a little antenna will stick out like a buoy, and then they will just begin to communicate and self-organize into a network.
Yeah.
And you got a self-organized. These kinds of visions, you know, this is what these guys were good at, and for them to even think that yes, in their lifetime anything like that would happen, this is what this program was all about. And for us to think of those kinds of things, that maybe in our lifetime something like that would happen, was very, very motivating.
Sure. So it was exciting more.
Yes.
Than
Oh yeah.
So I mean, they
cutting
thought
edge.
networks, and we thought in terms of responding to what they are thinking.
And Bob was a tough taskmaster.
Bob was
Demanding.
I mean, he was very demanding, and he was a visionary, and Vint was sort of different in terms of he could think ahead in terms of how you will be able to do that in software. I mean, his language was always.
You know, one of the stories that Bob, in fact, told last night. He may have mentioned it in his history thing. We were getting ready to bid. In fact, we gave him a bid for some additional radios. I think like 20 of them or so. And he went to his boss. I think it was Licklider at the time, and Heilmeyer, exactly. Heilmeyer, and I think the bid was like $47,000 a piece. I think the first one were about 85 or 90,000. So we had a bid for 47,000, and Heilmeyer says, "Well, how do we know whether that's a good price?" He says, "Well, there's this thing called an RCA price model, which is all based upon volume and weight, and it was a computer model that had loaded lots and lots of electronic pass things in it." They went down and ran that, and it came out $39,000. And Bob went back to Heilmeyer with that, and says, "Well, I guess it is a reasonable price." And Bob says, "I always knew." He says, "Collins has run that same model," and so you know he was always pressing the price and pressing to do something low cost. In fact, there was a program called Low Cost Packet Radio, and his bogey at that time was $5,000, and unfortunately Collins wasn't the winner of that competition, but I think we did have most of the packet radios that ever worked. So
He did say you were what, a Cadillac contractor.
yeah.
And in fact, our
They had
mistake.
a high confidence it would work.
Yeah.
Well, that was our mistake on that program, and actually we perhaps lost it more. We were just talking about it, that how practical Fran Dixon was in some of these respects. I mean, he said he misread DARPA on this one. He says, you need to remember whatever reputation there is, that when we say this we will do that. And even though they are asking for a $5,000 radio, but in the time frame they are asking for, we owe it to them what can be done. So instead of being responsive to the RFP, a lot of contractors lie during these bid processes. But Fran Dixon said, let's give them what we think can be done. And that's what we did. And obviously we were non-responsive, so we were sort of, I think, disqualified.
Yeah, I think so.
We should wrap up, I think, if we don't want to miss our own lunch.
Okay.
Is there anything burning that you guys want to say about your sort of a high-level notion of the way this perhaps changed your view of the world?
I would like to say this, that when I was writing my PhD dissertation, I used to think that this technology will lead to the first corporate command and control system of a kind, because we thought in terms of military applications, and to commercial migration, our vision was more in terms of what we call as the wide area networks today, that a large complex of a corporation could deploy a network like this and pretty much do things. We kind of saw security as a big issue in future with spread spectrum technology and all that. You couldn't have just fly-by-night guys driving around and try to jam your communication. So that was one of the visions we had, but we were not quite thinking of the impact it will have in future that we can anticipate now.
I think the big thing, from my thoughts, and I used to think about the commercial applications of this, and the problem was in 1977, this was really before the personal computer. I mean, this was really a computer communication system designed for that. I mean, voice and a lot of that stuff came later, but that was the intent. There weren't enough computers out there. In fact, I think I heard somebody say there's only 400 computers maybe in the Department of Defense or in that whole DARPA thing. So I think we missed, at that point, we couldn't envision that there'd be virtually billions of computers as there are today. And so I think that was sort of the mismatch, both from an understanding of a need as well as the technology to really make it economically viable. I mean, so much had to take place later from these basic concepts and these basic experiments to make this into what has become the results of it. So I think those are the two thoughts at the time was, gee, yeah, it works, but who needs it?
For me personally, I think the question was, what has this done for my outlook? Give me a great deal of confidence when I'm in a complete, total state of unknowns. And what I mean by that is that I've had major challenges since packet radio on major programs, development programs, still doing that type of work. And some people will say, well, do you think you can do this? And I've always reverted back to what I learned from the many years in working with these type of people and people at SRI. That is, well, I never knew what I was doing in the first place for everything I was given. I was always told, this has never been done. You've got 6 months and no budget. Go. And somehow, we always did it. And it's really built my confidence, something I've tried to transmit to my kids, that no matter what the obstacles or the brick walls are in front of you, if you're persistent and appreciate the people you're working with and keep an open mind, then you'll make it. I've never worked on another program since packet radio that was ever this much fun, this free meaning we truly were a brainstorming community with very little requirements. Requirements compared to nowadays, I get a military program, all the requirements are there, you'll meet that, don't even give us your other ideas. Obviously, Dr. Cerf and Dr. Khan had their visions of what they wanted. But at all the Packet Radio working group meetings I was at, I saw a complete freedom of exchange back and forth.
That's true.
Well, what do you guys think you can do? Well, what can you? Well, what do you want to do? At my level, I didn't hear many budget arguments, but I wasn't aware of any fallout from that either. And
Yeah.
for me, you know, we told them what we wanted to do. It was agreed, and 12 months, we'd go off and complete those tasks. And every time we did, everybody was successful.
And 12 to 14 hours days were norm for us without being paid for that.
Can I just cap this off by saying that I think at that particular time, both at ARPA, certainly at SRI, I can't think of a more, a better, more honorable group of guys, but also,
Dedicated.
but the fact that we could, I don't know whether we could go to another place in the country and
Yeah.
find the Collins quality.
We had that reputation being the
Yeah.
Cadillac
Yeah.
of communications
That's
industry.
nice to be remembered that way
Thank
too.
Great.
Thank you.